Okay, I'm delighted to be joined now by Ryan Kromhout. He is the manager of KROHNE's Global Food Industry Division. KROHNE Food and Beverage is a leading provider of measurement solutions for the food and beverage industry. With a focus on precision, reliability, and hygiene, KROHNE offers a wide range of products, including flow meters, level gauges, and pressure transmitters. These solutions help food and beverage manufacturers optimize their processes, improve quality control, and ensure compliance with industry standards. So, Ryan, welcome to Protein Production Technology International.
Well, thank you very much, Nick. Thank you for having me, and I appreciate the time that you spent with us on exchanging some of the knowledge that we have.
Not a problem, not a problem. Now, Ryan, given your extensive experience in the food industry, I'm curious to hear about your journey into the exciting world of alternative proteins. Could you share some insights into what drew you to this field particularly?
Yeah. Thank you. Good question. I started with instrumentation when I wanted to find out what is behind the added value of just a meter, like if it's measuring mass flow or volume. And this is how I got into the processing industry, by delivering instrumentation that would help the clients to produce their products a little bit better, or to tighten the production specifications and the tolerances. And from there onwards, you live your life. And in my life, a significant event happened when it was my son, in fact, when we were watching a movie which is called Game Changers, as many of you might know. When he then said, "Hey, Dad, you want to do this? You want to switch? You want to just cut meat?" And all the arguments, they made perfect sense to me. And that was the moment in my life that changed something for me. And when I decided to invest much more into the plant-based protein processing industry, and with all the expertise that I have, that I bring to the table, I hope I can bring some value and some additional benefits to this industry to help to develop this industry much faster than it already is.
Mm-hmm. Now, you've been involved in the industry for a good number of years now. You've witnessed significant transformations. How have you seen the alt protein landscape evolve, particularly in terms of consumer acceptance and technological advancements?
Mm-hmm. The plant-based protein consumption has been there all the time. So it has been in Asia, and they have shown us how to do this, how to process the plants, and how to adopt this. And we then have found ways to process the protein in such a way that it could be something that might make it easier for people to step over from the meat consumption or fish consumption to something which is similarly appealing to them. And the industry for itself has then grown as such that this kind of additional logic that you see, the one point that is good for your benefit, for your own health, and the other part that is very significant for the environment, what kind of CO2 footprint your food leaves on the planet, that this has rapidly increased the whole consumption. And this consumption and the acceptance, then there's a whole topic that you can talk about in a separate podcast, where I think there are some aspects of companies that are starting to believe in this is going to be the food for the future. One example, within the Netherlands, for example, one large supermarket chain is now blending plant-based protein to ground meat. Mm-hmm. And this in a 40-60 ratio. So you've got 40% being plant originated, mm-hmm, together with the meat that is being processed and produced as well. And thereby, you're already cutting 40% of the emissions that usually the animal-based meat would then cause. And this kind of new ideas, these kind of new ways of hybrid introduction of the plant-based protein concept itself will significantly accelerate the acceptances even more.
Mm-hmm. Yeah, that was a fantastic announcement from Lidl. In the Netherlands. I mean, as the alt protein market continues to expand, and there's been a few blips in the past few years, but overall, if we look at the trajectory from maybe a decade or so ago, it is expanding. Scaling up production while maintaining consistent quality is a critical challenge. You'll probably hear that from your customers all the time. What do you perceive as the biggest obstacles that producers face in achieving that balance?
What I find often in my discussions or just the dialogues that I have is that there is an enormous expertise about how to make the product. And that is then at the right point, at the right person. So those persons know exactly what they want to produce. What they might be lacking is the knowledge about how this can be processed. And the danger that I see is that on the current market, if you're producing a product, you're making a pilot batch, for example, or pilot scale productions, which are then for small batches to have some samples for the consumers to try and to see if it works. Then the moment from how to extrapolate it from that point onwards to something which is process scale, that is the challenge. And many of the bright people who have found ideas how to process plants to make it something which is very tasty and much liked by the consumer, then they will go to engineering companies who more than often copy just what they've done some 20, 30 years ago with meat processing, for example, because it's very similar, and copy this to be something which would be the possibility to upscale from a pilot plant production. And that ignorance is, I think, a little dangerous. So I would ask for all the people who are inventing and working in making new products within the plant-based industry to also challenge the way how this is being produced. And this is where KROHNE comes into play. That is, that we can replace weigh scales by a device which would be an inline weigh scale for that matter. So inline weighing of the actual ingredient, of the plant-based ingredient very precisely, but also to determine the density, to measure the density directly. So you've got the concentration and the composition of the product just right away. And that can then exchange the way you need to process from something which is a batch type, that if you start to put it into one mixing tank and then you add some additives that you weighed on a weigh scale before, you could potentially do this all inline. And with inline, you would eliminate the interrupt-based production. And you could just go ahead 24/7 without any interrupt if you then feed the tanks just before that. So inline blending, inline measurement technology for plant-based protein, I see is a unlocking factor for even faster growth from pilot scale to process scale.
Mm-hmm. And we'll be talking about that in the webinar at the end of September. Now, collaboration is key in addressing complex industry challenges. So how are you partnering with other industry players to develop integrated solutions to overcome the production hurdles associated with these alternative proteins?
That's a little fighting against the history and fighting against experience and fighting against pre-written or pre-designed skits or skit design as such. So we always have to convince that what we bring to the table is more beneficial to the production efficiency and also to the product quality. So the engineering companies, it is a little easier to do this with the mid-sized and smaller ones. The larger ones will mainly have an interest of, like putting not so much engineering effort into redesigning skits, but more to use the already existing skits to sell them to the market. So to make those older principles fit to the new product or the new foods as we have them now on the market. So this, excuse me.
Go on.
Yeah, and that just takes some time. And what I intend to do by making our product more famous is to have the people who are developing new products to know that there's a possibility to do this inline blending way of production and for easier upscaling, for tightening your production tolerances, and that the pull effect also comes from the final producers of the products.
Now, we consumers, and I count myself as a consumer, we see these products on the shelf, and I have no idea what goes into actually putting that product on the shelf. But precise measurement and data analysis are essential for optimizing production processes and ensuring product safety. So what role do you see these technologies playing in the future of the alt protein industry?
The foremost task is to make the product appealing to the client. So for a consumer to try, let's take an example of a plant-based product that is a substitute for tuna. If you will try this for the first time and the bite feel consistency is good, and he buys that a second time, the bite feel consistency should be the exact same. So to reproducibly produce products in a way so that you've got always the same kind of feeling. It's with your most favorite chocolates, probably the same, or the viscosity of the honey that you use, or your jam or your peanut butter. We as humans are always we've got our habits and we've got our ways of regarding things how they ought to be. And if you've got some surprises in that, that is one factor that the consumer usually doesn't like. The other part is then also the economy. So the economical aspect. If you've got very valuable proteins that are being, it takes a lot of effort in order to get them and to process them, and therefore they're valuable. You don't want to overdose or dispense them into products where you're not getting your money for. So that also that you're tightening your production tolerances. It could be a little over, a little under, and this you want to bring as close together to the ideal line as possible, and we help with that as well. So that would be all the engineer or machine builder companies for this matter as well. So this industry is really helping this acceptance of the products to the consumer market as well. And also making sure that you also have to face that, no contamination, that everything is in a hygienic design, that there can be no buildups and no bacterial growth and all these kind of aspects for food safety just as well.
Mm-hmm. Now, as well as being a consumer, and maybe we'll talk about some of our favorite products a bit later on. I also report on innovations in the industry, and there are tons and tons of them. How, for KROHNE, do you adapt your technology to accommodate all of these emerging production methods, like novel fermentation technologies and cell ag, etc.?
Yes. Very good question. If I have the product in mind, which to my opinion is the best fit for this industry, which would be a single straight tube mass flow meter, it resonates in natural resonance frequency, and by the fluid passing through, it deflects this motion and gives you the direct mass flow, but also the direct density measurement of this. This product is not intelligent. So the sensor for itself can only see the difference in phase shift, which is you would need to explain in order to derive the mass flow rate from it. But it doesn't make a difference between, let's say, chickpea concentrate or slurry, or soy concentrate or chocolate, or any kind of plant-based fats or that. So there I'm very fortunate. With that product, I can basically measure everything. The challenge has been also usually like the traditional producers. Of course, we've got competition, but we are the ones who have found a way to overcome the most difficult challenge. That is, if you've got liquids and you've got air pockets or homogeneously distributed air throughout the product, like a foam, or if you've got sporadic air inclusions in the product, or you've got a two-phase flow like what we measure, spinach with water and air inside, for example, like a three-phase flow even. There we have found algorithms to overcome this challenge. So by this, we, with this universal possibility to apply the sensor to so many different ingredients, we are well equipped for the demands that will come there. Mm-hmm. For fermentation, it is the most valuable ingredients that will go into the fermenter. Those are the ones who need to be measured the most precise way, of course. So because you don't, like I said, you always want to have the right amount in the process in order to get the same result time and time again, and you don't want to overshoot because of economical reasons. And the precision is also fine. The precision can maybe be increased by a 0.05% better reading or less error reading, for example, but not significantly. So we are very well geared for the future to come and for any kind of product that needs to be measured.
Mm-hmm. While this is a relatively new field, there's still much to learn from traditional food production methods. So what insights can plant-based or other novel food companies gain from these established processes?
The tightening the production tolerances for a large part. So what I think like moving away from this batch type processing to an inline processing method, as we say, like what could be applied to if you're working in a pilot scale environment up to process scale. That by at first you're eliminating all the say the switch over, I have to say it the other way around. You're eliminating all the deficits that you will have with product switchovers, or with one batch to the next one, like still stickage to the tank walls and those things. So that will be one part. But the other part is the precision that our instrumentation is measuring the fluids by. And this precision, what I mentioned before, so if you've got the tolerances, sometimes you undershoot a little bit, you're bringing this back to a very close ideal line that is bringing enough profit in order to do the justifications with a return on investment calculation for investing into better, higher quality measurement instrumentation.
Mm-hmm. One of the challenges I understand in processing plant-based foods, particularly, is slurries, handling those slurries. So, I mean, what are some of the difficulties in accurately measuring those sorts of materials?
Yeah. Also, very good question. That is the possibility that maybe many of the processing companies or the producers are not aware of yet. So if you imagine a slurry, which could be, let's say, a soy protein or soy concentrate or soy isolate. Yeah, concentrate, let's say it like that. That will have a very high viscosity. So it will be something which actually doesn't want to flow. And it behaves just like a solid a little bit. And the most appealing way to use it is to process it like if you were in a kitchen and then you put this into the bowl and you start mixing it, and that just on a larger scale. But you would not instantly come to the idea to put this through a straight piece of pipe in order to determine what the weight, what the density is, and potentially also what the viscosity is of this product. Mm-hmm. So that I would say is one possibility to make it more known that it is possible for these kind of slurries also with some solids inside. Like if there were some I don't know, particles or fiber or that others, as long as it flows, we can determine this by this inline measurement for the mass flow and for the density. And that is the possibility for changing these kind of production methods, and to think about that this could be a subject that could be measured just like a liquid, like a water would be, for example. Mm-hmm. And this change in mindset of regarding products, regarding fluids, if it is like a 1 or 2 or 3 phase flow, like 1 phase flow would be like the liquid would be pure but a little bit high viscous. 2 phase flow would be the liquid plus some air inside. A 3 phase flow would be the liquid, some air inside, and some fibers. That even these kind of challenges can be mastered these days.
Mm-hmm. Feedstocks themselves can vary widely in viscosity and density. So can your Coriolis mass flow meters handle these diverse properties?
Mm-hmm. Yes, what we have measured as my largest challenge was within a marzipan company in Berlin, for example. It's a mid-sized company who had said, we are changing, with my example, what I meant from batch type to inline measurement type of production. And marzipan is basically it's just crushed almonds. And that solid has enough oil inside so that if you crush it and if you stir it enough, it becomes this paste. And this paste, if it is not flowing, so if you're not increasing the shear stress for it to flow as a liquid, it will just be a solid. If you remember then for Christmas, for example, like with a little chocolate coating, you can eat the marzipan just like that. It's very traditional here in Germany as well. Mm-hmm. That we have amazed this client as well, that even though it basically behaves like a solid, it can be measured by the Coriolis effect. And we have not determined the viscosity because there's difference in viscosity if you measure this static or if you measure this in dynamic ways. So static would be in the lab, if you then take some penetration tests, for example, or if it is in the line, because you've got the shear stress in something. Imagine the famous tomato ketchup example, that at first it doesn't want to flow, but when it then flows in the middle section, it starts to flow very rapidly. These kind of symptoms we understand, and we help the clients to also understand what is happening inside their process piping. So by measuring the differential pressure across a certain distance, we can also help the client to understand what is the shear rate of this product. And also by knowing the shear rate of this product, you can also calculate back to how hard or how soft is my final product going to be in the end. So we're delivering more than just some key performance measurements than in these kind of slurries or even solids handling. Yeah.
Mm-hmm. Many ingredients used in this sector are sensitive. So what level of accuracy do your flow meters provide for those materials?
The level of accuracy is usually determined by an error that we say, like, what is the maximum error that you can expect from the sensor when it's built into the process? And the maximum error that we've got with our best sensor would be 0.05% of the measured value. So if you were to have 1,000 kilograms, 0.05 is too early in the morning for me to calculate, but it is minuscule. So it's
negligible.
Yep, absolutely.
Yeah. Process control is vital for optimizing production parameters. So how can your measurement solutions be integrated with process control systems to enhance efficiency and quality?
Yeah, the process industry and the instrumentation industry has advanced that much that virtually, just like you've got your DeepL or your Google Translate, it's the same. So we speak a certain language, and this language can be translated to all the languages that are out there in the automation world. So if it is a Profibus, if it is Ethernet IP, for example, IO-Link or CAN bus, like all the different communication protocols are existent, and we have to, as an instrumentation supplier, fulfill to those, of course. And the simplest way is 4 to 20 milliamp signal that we say, like 4 milliamps equals 0 and 20 milliamps equals, let's say, 10 tons an hour. And then a second milliamp would say 4 milliamp equals 800 kilograms per cubic meter, and 20 milliamps would equal 1,200 kilograms per cubic meter for the density. And then you've got the values coming into your process control system, and you can then process accordingly.
Another factor is obviously real-time analysis, which is invaluable for monitoring and troubleshooting production lines. So do your tools offer anything in terms of analyzing flow data and identifying potential issues?
The question comes in the right sequence, because previously you asked for the communication protocols, and this has broadened now. So there is much more bandwidth for our instrumentation to transmit to the actual user, including diagnostics. And there's this possibility with the diagnostics that we can say, like, look, there is something which is called the zero. So if the sensor is in a zero phase, if the flow is not flowing, just standing still, it will give you a certain reading. If this reading might have an offset to what it had a month ago, this might be an indication for something. And these kind of patterns we have then stored in our electronics. So it will not only say, like, I've got an offset in my zero, but it will say, is there additional pressure on the flow line? Did you change anything in the installation, for example? The same with buildup. That can also be the same. Temperature, of course, is a very easy one to determine and to detect. But also the indication if there is any unintended air in your process. So there is a signal which we call entrained gas, which then says from 0 to 100%. So do we have some unwanted air in our process, which could be like if you were running a fermenter, for example, and you're thinking you're dosing the very expensive liquid into it at 100%, but then you've got air bubbles, then you're not, and then your whole batch could be off. These kind of warnings we also give with the instrumentation.
I want to try and gain some insights into the benefits of using your technology. So are there any, not many companies like to talk about their clients, and I'm sure you won't mention any names, but can you share some examples of successful implementations of your solutions in this particular sector?
Yes. There is a possibility, for example, because we measure foams as well. And an example is from ice cream, which can be plant-based ice cream, of course, like vegan ice cream, or also traditional ice cream. Every ice cream freezer operates just like you were to produce ice cream at home, that you've got a frozen bowl and you start to stir the cream or the coconut fat, for example, in that bowl. And it will freeze on the frozen walls of the bin and starts to grow these kind of crystals. And therefore, there are machines that are called continuous freezers. So the liquid ice cream mix, which would be just imagine your cream, but then from coconuts, that would be fed to the freezer. And the freezer in the beginning, before it starts to produce, just like the fridge at home, it needs to reach its operating temperature, which is then low. So it needs to cool down the freezer tunnel. And this process takes about 20 minutes. And in the beginning of this, you're producing ice cream, which is not to the specification. So you're trying to dash air into this ice cream. And you have to imagine that an ice cream, let's take a very popular one, like I think I can mention Magnum, for example, just as the example that you've got a texture in mind. That this ice cream contains about 50% of air inside. So you've got the liquid, and then you're dashing 50% of air into this ice cream as well. In the beginning, because of the ice crystals have not developed that much, the matrix to hold those air bubbles inside is not fully developed. So the first 20 minutes, they're producing basically a product which cannot be sold. And until just recently, until we came into this discussion, the product had been de-aired and then sold off to farmers, for example, to have feedstock to feed this to the pigs, or to with a costly method to also rework it. Then you had to de-air it, then you had to pasteurize it again, and then you could bring it back into the vessels in order to blend it with fresh made ice cream mix in order to make new ice cream. What we've done is we have recirculated this rework ice cream, so the startup ice cream that is happening in the beginning for those 20 minutes, and fully integrated this back into the line. So basically, this ice cream is not going to be tossed or not going to be sold off to farmers as pig feed, but it's 100% being reused in this freezer. And this by the measurement technology that is able to measure the liquid and the air content inside. So even a foam like that, we determine how much air is inside for the freezer to know how much air does it still need to put in. And thereby we could reuse 100% of the rework ice cream for that example.
You mentioned Magnum before. I have tried their vegan ice cream. It's very good. It's very good. Now, before we come on to some concluding questions, what particular products have you tried, tasted, that you just thought, wow? And I'll give you a few examples. I've had this chicken thighs here in the UK, and it actually has a skin, a seaweed-based skin. They're incredible. What have I tried?
Seaweed-based.
Juicy marbles steak, very good. Redefined steak as well. That's very, very good. So tell me, you get around to a lot of shows and conferences. You're probably trying products all the time.
That's a really, really difficult one, Nick, because indeed there are so many, and then you have to align them with the right names. Let me not say any names, but let me just give examples of the products that I've enjoyed very much. Just recently, I've went to a place here in Germany. They've got to do with the city of Napoli, so it's a pizzeria chain. Not many, so I think like 8 or 10 different locations here in the Midwestern area of Germany, and they put chimichurri and meat onto a pizza, which I had the same experience as you had that you described just now. I just had a bite. The texture was fantastic. I saw it, and I offered this to our daughter, who's not 100% convinced yet. She said, you got steak. Why are you eating steak? And it just looked the same, and it tasted phenomenal. What was the other product that I just recently had? There was an algae product and plant-based prawns as well, which have really convinced me that this can be something for people who've got their habits of moving away from that kind of food product from farms, from shrimp farms, for example. Yeah, seaweed is a fantastic ingredient as well. I'm sorry, just too many. I wasn't really prepared on picking some of the good examples, but I enjoyed it.
No, I slipped it in there.
No. I mean, but on a positive note, because like you said, I travel around and I've got the possibility to try many different pilot products as well. And this journey is just fascinating me so much that indeed I'm not missing a thing by not eating meat anymore. And this for, what is it now? 4 years, 5 years already. So no, I'm a happy, how do they say, a happy camper in this, in trying all these kind of different developments in plant-based. Yeah.
And the exciting thing is there's a hell of a lot more to come. So based on that, looking ahead, what do you see as the most exciting developments or innovations on the horizon for this industry overall?
Yes, the hybrid, the possibility to have half and half, to have the possibility of winning a whole lot more consumers to this good cause, and thereby the very, very easy and quick fix for the CO2 footprint that meat has. That if you take actually the company Half and Half, for example, from the United States is an example like that, who openly communicates about this as well. Like Lidl, what we just mentioned before, the 40/60. The consumers will not see a difference in the appearance of the ground meat, and also in the tasting. They've done many tastings for this. They will also not truly notice that something has changed for the better. But if they then start to understand what they're doing actually with this consequence, or by this consequence, that they're cutting the CO2 footprint that the meat usually would have produced by 50% or 40% for that matter, that will be a very, very short-term significant improvement to what we're doing to the planet.
Mm-hmm. And how do you envision the role of your measurement technology evolving to meet the future needs of this rapidly growing sector?
Exactly, the blend of these two components together. So what I mentioned with the single straight tube Coriolis meter, we can measure meat. We can also measure any kind of plant-based concentrate in order to be blended with this. And this, you don't need to necessarily go through a mixing tank in order to do this. This can be easily done in line with a static mixer that will just swirl the different products around. And I see such a high possibility for increasing the efficiency of this production. So we're at KROHNE really targeting companies like the big meat producing companies, although I don't really fancy going there, but there is an openness to change. And that is really motivating and driving me as well. So because you've got this immediate possibility to impact the CO2 footprint with this possibility. And with our measurement technology, and not just the flow, but also the level in tanks and also the viscosity of the products, that will help this hybrid or this blending industry also to grow very much.
Well, look, Ryan, it's been wonderful to catch up with you. You hold a record because I've met you more times than anyone else in this industry. So that's twice. That's twice. But I'll meet you for a third time at the Future of Protein Production in Amsterdam. I'm very much looking forward to it. Ryan, thank you for your time. You're a great guy, and yeah, look forward to chatting with you soon.
Thank you. I always look forward to meeting you again, Nick, and thank you for inviting me for this interview and for the time. And I'm looking forward to seeing you in Amsterdam.
Been a pleasure.